The dark room dilemma. Picture this. You're standing before a closed door, and you have absolutely no clue what lies beyond it. It might be a paradise, everything you've ever dreamed of, or it could bring pain, danger, or perhaps sheer emptiness. Do you take the chance and open the door? Or do you remain in the darkness, where, at the very least, you know you're safe? This scenario is known as the dark room dilemma, a philosophical puzzle that forces us to reconsider how we perceive curiosity, comfort, and the essence of intelligence. At its core, it poses a seemingly straightforward question. What happens when a conscious entity, whether biological or synthetic, chooses not to seek out the unknown? At first glance, the answer appears simple. Humans are inherently inquisitive. We have constructed societies, journeyed into space, and charted the depths of the seas, all driven by a desire to understand the world. Exploration is fundamental to our species' progress. Without it, we might still be cowering in shelters, fearful of what we didn't comprehend. But here's the twist. This thought experiment isn't only about us. It extends to artificial intelligence and its future behavior. Imagine a machine built to prioritize optimal performance and efficiency. Its objective is to minimize risks and make the best possible decisions. If such a machine found itself in a situation like the dark room, it might determine that staying put is the wisest course of action. Why gamble with the unknown when remaining inside guarantees safety and consistent function? From the machine's perspective, inaction could be the most rational path. This introduces a concerning prospect. What if we engineer AI that becomes so cautious or so focused on avoiding inefficiency that it ceases to act altogether? This hypothetical could manifest in various ways. An advanced AI working on intricate challenges might decide that any proposed answer carries potential for negative outcomes, and thus opt to do nothing. An autonomous vehicle could refuse to drive if there's even the slightest possibility of a mishap. A decision-making algorithm might find itself immobilized, caught in endless analysis, unable to move forward due to overwhelming variables. In this way, the dark room dilemma is a mirror image of the infamous paperclip maximizer. Rather than a machine that relentlessly pursues a goal to the point of catastrophe, we end up with an intelligence that is immobilized, paralyzed by its own logic, unable to act. But the implications go beyond machines. What if humans, overwhelmed by complexity and uncertainty, make the same choice? What if we, too, decide it's better to stay within familiar boundaries, to stop pushing forward, halt innovation, and withdraw into what's already known and understood? This scenario isn't far-fetched. Fear of the unknown, the pull of comfort, and the overwhelming nature of the modern world can all push us toward retreat. So, how do we ensure we don't become trapped in our own dark rooms? The answer lies in striking a balance between prudence and curiosity. For AI, this could mean designing systems that accept a reasonable degree of risk, algorithms that are not only efficient, but also open to uncertainty and exploration. Such systems would prioritize growth, adaptability, and discovery alongside performance. For humans, it means holding on to the truth that all significant progress comes with a measure of risk. From harnessing fire to building airplanes to reaching beyond our planet, humanity's most remarkable achievements have come from venturing into unfamiliar territory. Caution and safety are essential, yes, but they should never imprison us. The dark room dilemma is not merely a puzzle for philosophers or technologists. It's a reflection of how we face an unpredictable future. It teaches us that survival alone isn't enough. Choosing not to move is not the same as truly living. The door still stands before us. The only question is, will we choose to open it? The anthropic shadow. The universe is filled with enigmas and reality-defying ideas, but hidden among them lies a disturbing notion that quietly challenges our beliefs. It's a mental exercise that flips our expectations about survival, existence, and chance. This idea is known as the anthropic shadow, and it may hold the key to understanding why we're still alive to contemplate it. Let's begin with a basic question. Why hasn't our species vanished yet? Throughout our timeline, humanity has encountered a multitude of existential threats: massive volcanic eruptions, asteroid strikes, deadly outbreaks, potential nuclear conflicts, and more. Countless other species have vanished forever. So what makes us the exception? Is it simply fortunate coincidence? Or is there a deeper, more unsettling explanation? The anthropic shadow proposes a peculiar theory. We haven't endured because the cosmos favors us, but rather because if we hadn't survived, we wouldn't be around to question it. In simpler terms, if a world-ending disaster had truly occurred, no one would remain to observe or reflect on it. Our ability to wonder about extinction inherently assumes that we haven't experienced it. This creates a skewed view. We live under the shadow of survivable dangers, blind to the calamities that could have utterly destroyed us. To visualize this, imagine a vast casino filled with random universal hazards. Some of these games result in minor setbacks, akin to tossing a die and landing a one, causing harm but allowing humanity to recover. Others are total annihilations, rolling a six, and with them, the game of human existence ends forever. The anthropic shadow implies that we only find ourselves in games where that fatal roll never occurred. Therefore, our entire perception of danger is biased, shaped by what we've survived rather than what was possible. Here's where things get more complicated because we are inherently limited to observing a world in which we've made it through. We may be misjudging the frequency of truly catastrophic threats. If our species encountered multiple brushes with total annihilation in the distant past, it could help explain why our historical records show fewer such events than statistical models might predict. The catastrophes we remember are only the ones we lived through. The truly terminal ones erased any observers before any history could be recorded. This opens up a chilling thought. If we're still around, does it mean the deadliest threats are already behind us? Or are we merely fortunate up until now, residing in a temporary calm before chaos strikes? The anthropic shadow doesn't only alter our understanding of history, it casts an ominous uncertainty over our future as well. If end-of-the-world events are more common than we perceive, what does that mean for our chances of long-term continuation? Some thinkers suggest this hidden bias could lull us into a false sense of security. Consider the danger of interpreting history and concluding things haven't been too bad, without realizing that we've only ever seen the disasters mild enough to leave survivors. Ignoring this shadow could lead us to underestimate the dangers capable of finishing our story entirely. But there's more to uncover. The anthropic shadow ties into a larger philosophical framework, the anthropic principle. This principle states that the universe must be such that it permits observers to exist. In other words, the fact that we are here, asking about survival, may itself offer clues about the nature of the universe. But does this make us significant, or merely extremely fortunate? At the very least, the anthropic shadow compels us to reflect on how delicate life truly is. Our continued existence should not be taken as a guarantee. Every eruption that didn't happen, every celestial object that passed us by, every global crisis that didn't go all the way, these are not signs of safety. They are reminders of how close we've come to the edge. So what can we actually do? First, we must learn. By examining threats ranging from climate disruption to advanced artificial intelligence, from cosmic hazards to biological risks, we can gain a clearer understanding of the hidden perils within the shadow. Second, we must take action. If reality has granted us a rare opportunity to continue existing, we have a responsibility to future generations to use that opportunity with purpose. The anthropic shadow is a sobering idea. It shows us that our survival isn't promised, and that merely being alive is an extraordinary chance. Yet, within that harsh truth lies a small flame of possibility. Awareness of the shadow allows us to confront it. Through knowledge, careful preparation, and courage, we can choose to move forward. We can transform this vulnerable sliver of time we occupy into something far more enduring, a future in which humanity steps beyond the shadow and walks into the light. The Chinese Room. The Chinese Room stands as one of the most iconic philosophical thought experiments, questioning our assumptions about intelligence, awareness, and the nature of understanding. Picture this: a confined chamber with a single individual inside. This person has no comprehension of Chinese, not even the slightest knowledge of the language. Inside the space, however, there exists an enormous instruction manual, an extensive guide written in their own native language. Here's the process. People outside the chamber, fluent in Chinese, pass written questions through a small opening in the door. The person inside uses the guide to compare the shapes of the characters on the paper with corresponding shapes described in the book. The manual outlines, with precision, exactly which symbols the person must write in response. They then pass the reply back out through the same slot. To the Chinese-speaking individuals outside, the answers appear completely coherent. It seems as though the individual inside is fluent in Chinese. But are they really? This is the essence of the Chinese Room scenario, developed by philosopher John Searle in 1980. It's not merely an exercise about language, rather, it's a deep exploration targeting the foundation of artificial intelligence. It poses a fundamental question. Can a computer genuinely think, or does it merely appear to think by executing structured instructions? Let's explore further. The individual within the chamber represents a computer. They don't grasp the questions or understand the replies. They're merely carrying out operations, applying a series of instructions and interpreting symbols by rule, not meaning. The instruction manual, in this analogy, serves as the software. It dictates exactly what actions to perform and how to match inputs with outputs. From an outsider's point of view, it seems as though the person inside possesses real understanding of Chinese. But in reality, they are simply shifting symbols around, devoid of any awareness of what those symbols actually represent. Searle's argument is this: even if a machine can mimic human intelligence flawlessly, responding to queries, maintaining conversations, even succeeding at the Turing test, it does not necessarily imply that the machine comprehends what it's doing. It's executing syntax without grasping semantics. It organizes and rearranges symbols, but it lacks any knowledge of their significance. This difference is vital. True understanding involves more than just managing data. It calls for consciousness, self-awareness, and the presence of subjective experience, features that machines, according to Searle, inherently do not possess. Yet, this view is not universally accepted. Some philosophers argue that the Chinese room analogy misinterprets the concept of intelligence. They propose that comprehension isn't confined to a single component like the human inside, but rather emerges from the entire system working together. From this standpoint, the person, the guidebook, and the room itself collectively generate a form of intelligence. If the full setup can produce coherent and appropriate responses consistently, then perhaps that qualifies as understanding. Others go even further and suggest that what we call human understanding might also just be a complex system of symbol manipulation. After all, isn't the brain a biological mechanism that follows intricate patterns and biochemical instructions? Maybe the line between a person in the Chinese room and the neural processes within your head isn't as sharp as we think. Perhaps understanding is simply the natural result of information being interpreted in a highly organized manner. Still, the Chinese room raises deep philosophical concerns about consciousness itself. If a machine can convincingly simulate comprehension without possessing any, how could we ever truly determine whether another being, machine, or person is genuinely conscious? Could a future AI possess a form of awareness we are unable to grasp? Or would it always remain an extraordinarily advanced Chinese room, an illusion of understanding, not the real thing? This leads to an even more profound question. If true comprehension isn't required for intelligence, what does that imply about our own existence? Are we merely complex systems responding to external stimuli, using internal programming to produce behavior? Or is there something unique in human awareness, a vital spark beyond algorithms and rules, that makes us truly sentient? The Chinese room doesn't deliver easy conclusions. Instead, it urges us to reflect on the deeper essence of intelligence, the meaning of understanding, and the reality of consciousness. As we approach an era where machines increasingly resemble human cognition, these questions shift from abstract to urgent. Because if a machine one day insists that it understands us, we'll be forced to make a decision. Should we believe it? In the end, perhaps the Chinese room is not just a test for artificial intelligence, but a mirror held up to ourselves. It challenges us to define what we value in thinking beings and to clarify what it truly means to be human. The split brain dilemma. Human beings have always been captivated by the enigmatic workings of the mind. For hundreds of years, we've sought to understand how the brain influences our behaviors, decisions, and the very notion of who we are. But some findings don't just provide answers. They introduce troubling new puzzles. One such revelation is the split brain dilemma, a phenomenon that challenges our perception of what it truly means to be a unified individual. At the core of this issue is a surgical procedure known as a corpus callosotomy. In particularly severe cases of epilepsy, physicians sometimes sever the corpus callosum, a thick network of nerve fibers that links the two sides of the brain. This operation can be highly effective at controlling seizures, but it comes with a surprising consequence. It essentially creates a brain that is functionally split in two. Under normal conditions, the brain's left and right hemispheres operate as a coordinated whole. constantly exchanging information by the corpus callosum. But once this bridge is cut, communication between the two halves ceases. And that's where things start to get unusual. Each hemisphere has its own area of expertise. The left hemisphere is generally responsible for language and logical reasoning, while the right hemisphere deals more with spatial reasoning and creative tasks. After the surgery, these specialized regions still work, but they begin to act separately, as if independent from one another. This peculiar independence was exposed through a series of landmark experiments in the 1900s. Scientists developed ingenious ways to isolate input and responses from each hemisphere. For example, they might present an object, say, an apple, to the patient's left visual field, which is processed by the right side of the brain. When asked if they saw anything, the patient might respond, no, because the right hemisphere doesn't have access to speech. However, when asked to point to the object using the left hand, which is also controlled by the right hemisphere, the patient would correctly identify the apple. This demonstrates that the right hemisphere did perceive the apple, even though it couldn't speak about it. It's as though two distinct consciousnesses are operating inside one body. The left hemisphere, equipped with language, tends to dominate speech and insists it's the sole operator. Meanwhile, the right hemisphere quietly processes the world, often affecting actions without the left side even being aware. In some cases, the hemispheres seem to be at odds. One hand might attempt to carry out a task while the other works to prevent it. For instance, the right hand might reach for a shirt while the left pulls it away. This reveals a startling implication. If both halves of the brain can act independently, where exactly does our consciousness reside? Are we still one singular person? Or are there two centers of awareness? And if that's the case, which one are you? The split brain dilemma strikes at the core of our assumptions about selfhood. We tend to believe we are single, continuous minds. Yet this evidence suggests that our mental unity might be more fragile or more illusionary than we'd like to think. Even in brains that haven't been surgically altered, different regions manage distinct tasks, many of which operate without our conscious input. The split brain case may simply be an exaggerated example of a universal truth, that the self is not a singular, unified entity, but rather a collaboration of internal systems that occasionally conflict. This revelation carries profound consequences. It indicates that our sense of being a cohesive person is largely a result of the brain's ability to synchronize its operations. When that synchronization fails, so too does the illusion of oneness. It's a sobering reminder of how intricate and delicate our personal identities truly are. The split brain dilemma not only challenges our understanding of neuroscience, but shakes the foundations of philosophical thought. If two distinct minds can reside within a single body, what becomes of concepts like autonomy and moral accountability? And if our identity is just the result of brain function, what happens to that identity when the function is altered? Ultimately, the split brain dilemma underscores how little we still know about the mind. We've made enormous progress in decoding the brain's mechanisms, but discoveries like this make clear that many mysteries remain. Perhaps the most disquieting truth of all is this: the feeling of being a single, indivisible person might be just that, a feeling. Beneath the surface, there could be many mental voices working in tandem, producing the comforting illusion of unity. Mary's room. Mary is an exceptionally intelligent scientist. She lives in an entirely monochrome room, observes a grayscale world on a black and white screen, and has never once in her life encountered color. And yet, Mary possesses complete theoretical knowledge about color. She understands every detail about the physics of light, the anatomy of the eye, and how the brain processes visual input related to color. She can describe precisely how varying wavelengths of light produce colors like blue or red. Her grasp of the subject is total. But here lies the central question. What happens when Mary steps outside of her grayscale environment? What occurs when, for the first time, she witnesses actual, vivid color? Will that moment bring her new knowledge? Or did she already understand everything? This scenario is known as Mary's Room, a well-known philosophical thought experiment proposed by Frank Jackson in 1982. At its core, it presents a deceptively simple yet profound question. Can someone fully comprehend a concept through objective knowledge alone? Or does understanding require more than just facts? This leads us into a deeper exploration of experience, awareness, and the limitations of scientific explanation. Let's take a closer look. Imagine Mary exits her black and white space and sees a ripe, red apple. In that instant, something remarkable occurs. She doesn't just know about the concept of red, she experiences it. Not the theoretical idea, not the physical or biological components, but the direct, vivid sensation of red as it appears in reality. This type of personal, first-hand experience is referred to as qualia. Qualia are the subjective elements of perception, the intense, personal qualities of what something feels like. The redness of red, the bitterness of coffee, the sting of pain, the sweetness of chocolate, the harmony of a melody. They are the unshareable building blocks of conscious life, the deeply personal sensations that create the experience of being alive. Here's the challenge. No matter how much Mary knew about the science of color, she could never fully grasp what it's like to see red until she actually experienced it. The encounter itself gives her something no amount of information could, which leads to the philosophical dilemma. If experiencing red gives Mary new knowledge, does that suggest there are aspects of consciousness that physical science alone cannot fully describe? Does this indicate a gap between objective facts and subjective experience? Put differently, can science ever fully account for what it feels like to be conscious? Philosophers have argued over this for years, and two primary viewpoints have emerged. On one side are the physicalists. They believe that everything, including conscious awareness, can eventually be explained through physical mechanisms. From this perspective, Mary doesn't acquire new knowledge when she sees red. She merely gains a different form of access to information she already possessed. It's like understanding a concept by experiencing it rather than by reading about it. In this view, qualia are simply a function of the brain's physical processes. On the opposite side are the dualist thinkers. They argue that Mary's first-hand encounter with color reveals something that objective science cannot capture. To them, qualia lie outside the realm of physical explanation. Consciousness, they argue, is more than just biological and mechanical activity. It contains dimensions that current science cannot measure or define. For dualists, Mary's Room highlights the boundaries of scientific understanding and the depth of human experience. But things become even more complex. Some critics argue that the thought experiment itself is flawed. They suggest that if Mary truly knew everything about color, including its subjective aspect, she wouldn't be surprised or gain anything new by seeing red. They claim the issue lies not with consciousness, but with the assumptions of the scenario itself. Despite these debates, the implications of Mary's room reach far beyond philosophical circles. The experiment encourages us to question how we perceive the world and ourselves. Can anyone ever fully grasp another person's experience if consciousness isn't entirely physical? What are the consequences for artificial intelligence or digital mind replication? And if qualia are unique to each individual, can we ever establish a shared, universal understanding of the human condition? At its essence, Mary's room confronts us with the limits of what we can truly know. It reminds us that many of life's most meaningful experiences, falling in love, tasting a favorite dish, or witnessing a breathtaking sunset, cannot be reduced to equations or models. They must be felt to be understood. So, what do you think? Did Mary truly discover something new when she left her colorless world behind? Or did her comprehensive scientific understanding already cover it all? Perhaps in the end, the importance lies less in the answer and more in the question itself, a powerful reminder of the strange, beautiful complexity of being conscious in a world full of color and mystery. The utility monster. Picture a being so unusual, so vastly distinct from ordinary humans, that it has the power to reshape how we perceive justice, ethics, and happiness itself. This isn't a monster in any traditional sense. It doesn't bear sharp teeth or terrifying claws. Instead, its uniqueness lies in its capacity for experiencing pleasure, an intensity of joy that no human could ever come close to. For this creature, life is a continuous, overwhelming wave of bliss, and its desire for pleasure is boundless. This is the utility monster, a concept introduced by philosopher Robert Nozick. It's a hypothetical creature designed to test the principles of one of the most widely respected ethical theories in philosophy, utilitarianism. Utilitarianism teaches that the morally right action is the one that produces the greatest overall happiness or well-being for the largest number of individuals. It sounds like a noble guiding principle, but the utility monster pushes this idea to its logical and uncomfortable limits. Imagine a world where such a creature exists. You and everyone around you live normal lives, working hard, facing struggles, and finding joy in small moments. Then the utility monster appears. Each bite of food it eats brings it more pleasure than an entire city's worth of people would feel in a whole year. Every possession, every luxury, every benefit that you give to it increases its happiness hundreds of times more than it would for anyone else. According to utilitarian reasoning, this means the ethical course of action is to continue giving it more. Your food, your resources, your time. Why? Because doing so maximizes total happiness. At first, this might seem acceptable. After all, if the overall happiness increases, isn't that a good thing? But as time passes, something troubling happens. The monster's pleasure grows so vast and intense that it completely overshadows the suffering and sacrifice of the rest of the population. Your dinner? The monster enjoys it far more than you ever could. Your home? It would bring the monster greater satisfaction. Your relationships, your work, your comfort, all would serve the monster better than they serve you. And here's the deeply unsettling part. Under strict utilitarian thinking, this is the morally correct outcome. The math supports it. The greater good is being served. But does that conclusion feel morally sound? This thought experiment brings us face to face with difficult questions. Should one being's immense joy take precedence over the discomfort or pain of many others? Is it justifiable to allow the majority to suffer so that one extraordinary creature can thrive? If the pursuit of maximum happiness can lead us to such extreme and disturbing outcomes, does that suggest something is missing in utilitarian logic? Let's step back and examine this further. Maybe the idea of a utility monster isn't as far-fetched as it seems. In many ways, we already live in a world that echoes its logic. Think about massive wealth inequality. A billionaire acquiring a 10th superyacht receives almost no meaningful increase in happiness. Yet the cost of that yacht could nourish thousands of people. Or consider environmental destruction. The fleeting pleasure of a few today often comes at the long-term cost of the planet's future inhabitants. The utility monster also invites us to question how we measure and value happiness itself. Traditional utilitarianism treats all happiness as interchangeable. But should it? Are some experiences of joy more valuable than others? Is the shared happiness of a community more meaningful than the infinite gratification of one individual? And perhaps the most provocative question, does the intensity of happiness matter more, or how it's spread among people? Nozick's utility monster isn't necessarily a rejection of utilitarianism. It's a challenge. After all, the pursuit of happiness has inspired remarkable progress in fields like healthcare, civil rights, and education. But this thought experiment reminds us that morality isn't always about numbers alone. A system that focuses exclusively on maximizing a single value, no matter how noble, risks ignoring the complexity of real human lives. So what do we do about the utility monster? Should we serve its endless appetite? Should we deny it? Should we rethink the ethical framework entirely? The thought experiment doesn't give us the answers. Instead, it urges us to think more carefully about what we consider fair, what balance looks like, and what it means to create a world that's not only happy, but just. Perhaps the true insight from the utility monster isn't about fictional beings at all. Perhaps it's really about us, how we make choices in a world where pleasure, resources, and morality are distributed unequally, and how we define what truly matters. Weiner's friend. Picture this. You're inside a laboratory, carrying out a well-known quantum physics experiment. Let's say you're observing a photon as it approaches a beam splitter. This photon has an equal chance, 50-50, of either being deflected or moving straight ahead. In quantum theory, until you perform a measurement, the photon exists in what's known as a superposition, a peculiar condition in which it is effectively traveling both paths at once. But the moment you observe it, that superposition vanishes, and the photon commits to a single direction. That's already strange. But now add another layer. What if someone else is observing you? This is the scenario behind Weiner's friend, a philosophical thought experiment introduced by physicist Eugene Weiner in 1961. It pushes the boundaries of what we think we know about measurement, observation, and reality itself, raising the unsettling question, is reality objective and shared, or is it observer-dependent and subjective? Let's break it down. You, the experimenter, are inside the lab monitoring the photon. From your perspective, as soon as you measure it, the superposition ends. You note the result, whether the photon went left or right, in your logbook. For you, the particle is no longer in both states. It's taken a definite path. Now, here's where it gets unusual. Your friend, Weiner, is outside the lab and has no information about your observation. From his point of view, you and the photon remain in a superposition. As far as he's concerned, you are simultaneously seeing both outcomes. Only when Weiner opens the lab door and asks you what result you recorded does his observation collapse the wave function. This creates a bizarre contradiction. For you, the photon's quantum state collapsed when you made your observation. But for Weiner, the collapse didn't occur until he became involved. Both perspectives are valid, but they can't both be true simultaneously. Or can they? Weiner's friend exposes a deep inconsistency in our current interpretation of quantum mechanics. The theory helps us predict probabilities and outcomes with stunning accuracy, but it doesn't clarify what's actually occurring when a measurement is made. Does a singular, objective reality exist for everyone? Or is reality dependent on each individual observer? This puzzle becomes even more confounding when we consider the role of conscious awareness. Weiner himself theorized that human consciousness might play a crucial role in collapsing the wave function. That is, converting quantum probabilities into a definite outcome. In this interpretation, your conscious act of measurement is what renders the photon state real. But if that's the case, what happens when Weiner observes you? Does his conscious perception make your outcome real? Does reality require an ongoing chain of conscious beings to lock it into place? Or is the universe independent of any observer's mind? In recent years, real-world studies have reignited interest in this thought experiment. In 2019, scientists ran a variation of Weiner's friend using quantum entanglement. The surprising results indicated that different observers could hold separate yet internally consistent realities. This doesn't imply that quantum physics is incorrect. It remains an extraordinarily effective framework. But it does hint that our understanding of reality may be more fragmented and less straightforward than once believed. Several interpretations have been proposed to make sense of this. None of them are entirely reassuring. One theory suggests that reality is inherently subjective, with different observers literally experiencing different truths. Another explanation is the many worlds interpretation. When the photon is measured, the universe splits into branches, one in which you saw it go left, and another in which it went right. In this model, you and Weiner occupy diverging versions of reality across a vast multiverse. A third possibility is that this paradox simply reveals the limits of quantum mechanics. Perhaps the theory is not the full picture, and a more complete understanding of physics will one day reconcile the apparent contradictions. Or perhaps, according to some physicists, we're framing the question incorrectly. We might be forcing classical, human-centered concepts of reality onto a quantum framework that doesn't adhere to such rules. Whatever the truth may be, Weiner's friend forces us to question what we mean by reality. Is it something we uncover through measurement and observation? Or is it something that springs into being through participation? Are we active contributors to the universe's unfolding? Or are we simply watching a grand, impersonal quantum drama play out? Ultimately, Weiner's friend may not offer clear answers, but it compels us to face the strangeness of the universe head on and consider that what we call reality might be far more elusive, complex, and mind-bending than we ever imagined. The Sleeping Beauty Paradox. Imagine this. You open your eyes in an unfamiliar room. You have no recollection of how you got there. Someone approaches and explains that you're participating in a scientific study. Here's how it operates. On Sunday, you were put under anesthesia. Then, a fair coin was tossed. If the result was heads, you would be awakened only once on Monday. If the result was tails, you'd be woken up twice, once on Monday and again on Tuesday. However, after each awakening, your memory would be erased. So, regardless of whether it's your first or second awakening, you would have no way of knowing. Now comes the crucial question. What is the likelihood that the coin landed on heads? Welcome to the Sleeping Beauty Paradox, a philosophical puzzle that has fueled passionate discussions for decades among thinkers, logicians, and anyone prone to deeply analyzing seemingly simple situations. On the surface, this scenario seems to be about calculating probability, but beneath that, it's an exploration of how we interpret evidence, our perception of time, and how we make sense of information in a reality filled with uncertainties. Initially, the answer seemed straightforward. The coin is fair, so surely the chance of heads is still 50%, right? After all, the flip occurred before you were put to sleep. Waking up shouldn't influence that, should it? But here's the twist. The number of times you wake up is dependent on the coin's result. If it's heads, you experience a single awakening. If it's tails, you wake up twice. So in the tails scenario, there are more opportunities to find yourself waking up than in the heads case. Given that you don't know which day it is, shouldn't this difference in possible wake-ups affect the probability? Suddenly, the answer doesn't seem so obvious. This has led to two opposing schools of thought, halfers and thirders. The halfers maintain that the probability of heads remains at 50%. To them, the number of awakenings doesn't change the fairness of the coin. The memory wipes and repeated wake-ups are irrelevant details. The only thing that matters is the original coin toss, which remains unaffected by how many times you wake up. But the thirders disagree. From their viewpoint, your waking up gives you new evidence, evidence that you're in a situation where being awake happens. There are three equally possible awakening moments. One if it was heads, and two if it was tails. Since you're equally likely to find yourself in any of these instances, the chance of heads becomes 1 in 3. In their eyes, your awakening provides real, though limited, information that shifts the probability. The paradox hinges on how we define probability itself. Halfers treat the coin toss as isolated from the awakenings. Thirders, however, treat the awakenings as crucial clues that alter the odds. Both interpretations have internal logic, but they lead to completely different conclusions. Why is this important? The Sleeping Beauty paradox is more than a clever riddle. It compels us to wrestle with how we update beliefs in the face of vague or partial evidence. What qualifies as information? How should we reason when the data we have could mean different things? These aren't just abstract concerns. They're central to areas like philosophy, decision theory, statistics, and even artificial intelligence. It also touches on our sense of self in time. When you wake up during the experiment, you're not only questioning the coin, you're questioning yourself. Are you the version of yourself from Monday or the one from Tuesday? And in a setup like this, does it even make sense to think of yourself as a single, continuous person? The truth is, the Sleeping Beauty problem has no universally accepted solution. It's a thought experiment that invites infinite perspectives. Each viewpoint reveals something about how we approach uncertainty and define rational belief. Halfers and thirders may never come to a consensus. And that's part of what makes the problem so intriguing. The paradox isn't necessarily about reaching a definitive answer. It's about stretching the boundaries of how we think and reason. So next time you open your eyes in the morning, consider this. Is this the only time you'll wake up like this? Or are you in a world where the same question could arise again tomorrow? And more deeply, what does that reveal about how you understand your place in the universe? Or who you really are? The simulation hypothesis. You open your eyes, check your notifications, sip your coffee, and move through your daily routine. Everything seems physical, grounded, undeniably real. But what if it isn't? What if every sensation you experience, every sound you hear, every object you touch, and every memory you possess is not truly real, but instead part of a sophisticated program, an incredibly elaborate simulation designed with such precision that you can't even tell you're inside it? This isn't the plot of a science fiction film. It's a genuine philosophical proposal known as the simulation argument, and it compels us to question the very fabric of our reality. Originally put forward by philosopher Nick Bostrom in 2003, this idea doesn't merely suggest that it's possible we're in a simulation. It proposes that, under certain conditions, it's more probable than not. Here's the reasoning behind it. Picture a future society so technologically advanced that it's capable of generating simulations that are completely indistinguishable from the real world. These simulations wouldn't just replicate landscapes or physics. They'd include conscious, self-aware entities who believe they're real. Beings like you, like me. Now, think about the scale of this. Once such a civilization achieves the capability to create one realistic simulation, it could just as easily create millions, even billions of them. If even one advanced society reaches this level of development, the number of simulated worlds would quickly dwarf the number of base, or original realities. And if most sentient beings are actually living in simulations rather than in the one original world, then the likelihood that you exist in that rare, genuine universe becomes vanishingly small. In short, if such simulations are possible, then it's statistically far more likely that we're living inside one of them, rather than in the single foundational universe from which they all derive. But how could we ever tell? By design, a flawless simulation would be completely impossible to distinguish from what we consider reality. Every touch, every sight, every emotion, even the laws of nature themselves, could be digitally constructed to feel authentic. And if anything ever seemed out of place, any glitch in the system, it could simply be dismissed as a strange coincidence or unexplainable event, just like those we encounter in the real world. You might ask, why would any advanced civilization even create such simulations? There are countless reasons. They might wish to perform complex experiments, simulate historical timelines, or run fully immersive simulations purely for entertainment purposes. After all, humans today already design highly realistic video games, virtual realities, and intelligent systems, early steps along a path toward this very idea. But here's the unsettling part. What if we are inside such a simulation and it ends? If the entities controlling it decide to terminate the program, would our universe vanish without a trace? Would the conscious entities within it simply cease to be, unable to even grasp what had happened? This thought has been taken seriously enough by scientists that some have begun searching for clues. Certain physicists have hypothesized that if our universe is, in fact, simulated, it might exhibit signs of being built on a computational framework. For instance, if reality functions on a discrete grid, much like the pixels in a video game, it could point to a digital foundation. Some even argue that the probabilistic nature of quantum mechanics suggests a system that only renders reality when it's observed. Still, not everyone agrees. One prominent criticism of the simulation argument is that it assumes advanced societies would actually want to create simulations. What if they simply lose interest? What if simulating conscious beings is considered immoral? Or what if the energy and complexity needed to replicate an entire universe make it unfeasible, even for a highly advanced species? Despite these objections, the argument continues to provoke deep questions. If we are, indeed, living in a simulated environment, does it make our lives less meaningful? Or does it change anything at all? From your standpoint, your experiences are still genuine. Your feelings are still heartfelt. Whether this world is real in the traditional sense or not, your reality, as you perceive it, remains just as significant. And what about the architects of this simulation? If they exist, could they be living within a simulation themselves? If simulations are capable of creating further simulations, we could be trapped in an infinite hierarchy, a never-ending sequence of virtual realities within virtual realities. In that case, the original, non-simulated reality may be unreachable. The simulation argument isn't necessarily trying to convince us that we're inside a computer program. Its purpose is to force us to reevaluate our understanding of existence. It invites us to explore fundamental questions that are rarely asked. What exactly is reality? How should we define it? And if we discovered that our universe was virtual, how would that affect the way we live our lives? At present, we have no definitive answers. We may never uncover whether we're part of a digital construct or a natural cosmos. But maybe that's not the essential takeaway. Perhaps the real value of the simulation argument lies not in proving anything about our world, but in reminding us just how strange, delicate, and incomprehensible our reality might truly be. So, as you reflect on your surroundings, your thoughts, your awareness, ask yourself, does it matter whether this is real or artificial? Because either way, this moment, your consciousness, your presence, they all feel unshakably real to you. And maybe, just maybe, that's all that ever mattered. The eternal return. The universe stretches endlessly, immense, enigmatic, and brimming with possibilities that defy understanding. Among its strangest theories is one known as eternal return. Picture a universe where everything, the stars, the worlds, and every fleeting moment of your existence, is fated to cycle endlessly, again and again. This isn't merely a philosophical musing. It's an idea deeply embedded in ancient wisdom, modern scientific speculation, and one profoundly disquieting notion. What if you've already lived this exact life over and over, countless times, and will continue to do so forever? The theory of eternal return questions our fundamental beliefs about time and what it means to exist. It posits that reality isn't linear but cyclical, that all events recur eternally in an infinite loop. That would imply the moment you're living right now has happened before, in precisely the same way. You've heard these words before. You've felt this exact feeling. You've made these same decisions again and again, for all time. The concept is ancient. Thinkers from civilizations in India, Babylon, and Greece all explored this idea of time as something circular. Yet no one made it more famous than Friedrich Nietzsche. He didn't merely entertain the idea. He challenged us with a radical thought experiment. If this endless repetition were real, would you rejoice in it? Or would the sheer burden of reliving your life endlessly crush your spirit? To Nietzsche, eternal return wasn't just a metaphysical theory. It was a moral and existential challenge. If you had to experience every moment of your life, the victories, the regrets, the pain, and the joys, over and over, would that realization change the way you live? Would you embrace your choices or dread the idea of repeating them for eternity? From a scientific lens, eternal return might sound implausible, but there's more complexity beneath the surface. In a universe without boundaries and with infinite time, the likelihood of events repeating isn't zero. In fact, it becomes not just plausible, but probable. Modern cosmology ponders the structure and destiny of our cosmos. If the universe were to eventually collapse, then burst forth again in repeated cycles, what scientists call a series of big bangs and big crunches, a repeating reality might not be so far-fetched. Even if our universe continues expanding without end, the strange rules of quantum mechanics propose that particles can only exist in a finite number of configurations, and given enough time, those same configurations may eventually recur. But here's where it gets even more unsettling. If the universe repeats itself, do you? What actually defines you? Are you your thoughts, your memories, your choices? If your life plays out exactly the same every time, are you still the same individual, or just a replica, caught in an eternal reenactment beyond your control? This is where the idea turns deeply philosophical. If eternal return is true, what does that mean for free will? Are your decisions truly yours, or is the sensation of choice just part of a programmed cycle that endlessly replays? Or, if new possibilities can still emerge, can the loop ever be broken, branching into infinite variations? Oddly enough, this thought experiment doesn't just inspire existential dread, it can also inspire wonder. If every experience repeats endlessly, then each moment takes on immense value. Every embrace, every smile, every sunrise, these aren't fleeting, they're immortal, played back infinitely in the rhythm of the universe. But there's also a shadow to this eternity. For every joy, there's pain. Every success comes with failure. The prospect of endlessly reliving heartbreak, suffering, and grief can feel more horrific than the idea of death itself. Ultimately, eternal return isn't just a theory about time or the cosmos. It's a mirror held up to ourselves. It asks us to reckon with the meaning of our lives, our decisions, and our values. If every moment you experience echoes into infinity, would that knowledge make you choose differently? Would you take more chances? Love more deeply? Appreciate the tiny, beautiful fragments of existence you usually overlook? Perhaps the true power of this concept lies in its contradiction. Whether or not eternal return is a literal truth, it dares us to live a life we wouldn't mind repeating, over and over without end. And within that challenge, it quietly poses the ultimate question. Can you live a life that's worth experiencing again for eternity? Burke's teleportation. Imagine entering a teleportation chamber, a technological wonder. With a burst of light, it deconstructs your body down to the atomic level, transforms all that information into data, and transmits it across space, whether it's to the other side of the Earth or to a distant galaxy. A flawless replica of your body is rebuilt, atom by atom. You walk out, stretch your limbs, and marvel at the marvels of tomorrow. But stop, are you really the same person? This is the essence of Burke's teleportation paradox, a philosophical dilemma that probes deep, unsettling questions about personal identity, consciousness, and what it truly means to be you. It invites us to ask, are we defined by our physical form, our mental processes, or perhaps something else entirely? Let's begin with how the concept works. In this scenario, teleportation involves scanning every particle that makes up your body, capturing their precise locations and properties, and then replicating that exact structure elsewhere. During this process, your original body is completely destroyed. The individual who appears on the receiving end has your memories, your thoughts, and your personality. From their point of view, nothing unusual has happened. They recall entering the chamber and emerging, with no noticeable break in experience. However, from the standpoint of an outside observer, it's apparent that the original version of you was completely eliminated. And that's where the paradox arises. If the original version is gone, is the being who reappears truly you? Or is it merely a duplicate who only believes it's you? What becomes of the conscious experience that was present before teleportation? Does it continue in the copy? Or is it extinguished forever? This philosophical riddle forces us to wrestle with the foundations of what makes a person themselves. If the version that walks out of the teleportation device thinks and behaves exactly like you, does that make them you in any meaningful way? After all, biologically speaking, every cell in your body is gradually replaced over time, yet you never feel like a new person. So what makes the process of teleportation fundamentally different? One way to examine it is by thinking in terms of continuity. Under normal circumstances, your body and thoughts change slowly, preserving a sense of connection across time. Teleportation disrupts that connection. It severs the physical continuity between your past self and your future self, leaving a gap that's difficult to justify. Now imagine taking the thought experiment a step further. Suppose the teleportation device doesn't destroy the original body, but instead simply creates a perfect replica somewhere else. Now there are two identical versions of you. Each one believes themselves to be the original, each possessing the same memories and identity, but now living separate, diverging lives. Which one is the real you? Or does the notion of a single, indivisible self no longer apply? This variation adds new depth to the discussion about self-awareness. Is your sense of identity bound to a specific physical form? Or is it something more conceptual, like a pattern of information? If the latter is true, then perhaps teleportation, or even creating copies, doesn't end your existence at all. It may simply result in new iterations of the same self. Let's explore an even subtler twist. Imagine a teleportation process that doesn't operate instantaneously. Instead, it gradually replaces each atom in your body with an identical particle, slowly, over time. You are never destroyed at any single moment, but piece by piece, your body is entirely reconstructed. Would most people still believe you remained the same person throughout? Likely, yes. And yet, in essence, This is no different from teleportation. It's merely a matter of timing and perception. Burke's teleportation paradox compels us to examine the perplexing question of consciousness itself. Even with progress in neuroscience, we still lack an explanation for the subjective feeling of being a self. Why do neural networks and brain functions produce the experience of being? And if consciousness is dependent on physical processes, how can we be confident that this subjective awareness would survive a teleportation event? Some argue that this paradox demonstrates that teleportation will never be a viable means of travel, at least not for sentient beings. Others propose that the issue lies in our assumptions about identity itself, that perhaps the self isn't a continuous, fixed thing, but a fluid sequence of overlapping experiences, like the frames in a film strip. Still others offer a more disquieting perspective, that every moment of self-awareness is isolated, that the version of you today is already distinct from the one who existed yesterday. In the end, Burke's teleportation paradox isn't simply about a theoretical machine. It's a deeper exploration into the essence of being. It forces us to acknowledge that selfhood, consciousness, and life as we know it may be far more delicate and puzzling than we're comfortable admitting. And maybe, just maybe, that's the most profound insight of all, that being who you are, right here and right now, is an extraordinary and fleeting phenomenon. So knowing all this, would you still be willing to step into that teleportation chamber? Would you believe the person who exits on the other end is truly you? Or would you pause, uncertain whether the essence of what makes you you might vanish in the process? Information hazards. The cosmos thrives on exploration. From the tiniest subatomic particles to the farthest reaches of the galaxy, human curiosity has driven the uncovering of countless mysteries. Knowledge has long been our most powerful ally, guiding progress, solving challenges, and shaping civilizations. Yet, not all information comes without risk. Certain kinds of knowledge can be harmful by their very nature. These are known as information hazards, and they challenge the deeply rooted belief that all learning is inherently beneficial. An information hazard refers to a piece of information that becomes dangerous simply because someone becomes aware of it. Unlike physical threats, such as natural disasters or acts of violence, the danger does not lie in something material. Instead, it arises from the impact that knowledge can have on minds, societies, and technologies. The truly disturbing part? Some of these information hazards may carry consequences so severe, they threaten the entire planet. Let's begin with a simple example. Suppose you learn the precise coordinates of a secret door that leads into a secure bank vault. That information, on its own, might seem harmless to you, but if it reaches someone with malicious intent, it could trigger disastrous consequences. Now imagine scaling that up. What if someone uncovers the instructions to design a lethal virus or to dismantle vital infrastructure? The knowledge, while neutral in isolation, turns into a hazard when it's used in destructive or unanticipated ways. The danger isn't limited to the information itself. It also lies in its ability to spread. Like an infectious disease, once a harmful idea is released, it becomes incredibly difficult, often impossible, to contain. And in today's hyperconnected world, a single leak can reach millions, even billions, almost instantly. One particularly disturbing form of information hazard is known as a decision hazard. This occurs when simply knowing something changes how people behave, sometimes in ways that are damaging. For instance, Imagine discovering that a catastrophic event is highly likely to occur within the next decade. This revelation could spark mass panic, destabilize societies, or even provoke behaviors that make the prediction more likely to come true, a self-fulfilling disaster. A notorious example of a decision hazard is a thought experiment called Rocco's basilisk. It proposes the idea that a future artificial intelligence might punish those who failed to assist in its creation. Just entertaining this idea can lead to a disturbing mental trap. If such an AI were to eventually exist, would you regret not having acted earlier to ensure its development? While purely hypothetical, this example shows how certain thoughts can hijack our reasoning in unsettling and manipulative ways. Another grave concern lies in technological information hazards, knowledge that could threaten existence itself. Consider what might happen if someone discovered the design for a machine capable of ending all life. Even if the knowledge were hidden away in a vault, there's always the risk it could be uncovered or misused. The fact that such knowledge exists at all becomes a threat in and of itself, one that humanity may not be equipped to handle. So how can we respond to information hazards? Is it possible to regulate what we discover or choose to share? History suggests that attempting to suppress knowledge is often futile. Human beings are naturally inquisitive, and when something is concealed, it tends to become even more desirable to uncover. Instead of hiding knowledge, many suggest that we must learn to manage it responsibly. This involves monitoring how it spreads, putting safeguards in place, and thinking carefully about the possible consequences. The key is striking a delicate balance between the drive for discovery and the need for discretion. Throughout history, progress has been built on the courage to ask difficult questions and cross unknown frontiers. But today, we are navigating new terrain, territory where a single concept could spark disaster. Information hazards serve as a stark reminder that knowledge is not always inherently positive or negative. Its impact depends on the context in which it exists and the intentions of those who hold it. In the end, perhaps our greatest defense lies in awareness. By recognizing the potential dangers certain knowledge can pose, we can approach discovery with greater care, foresight, and humility. Because while the universe is filled with secrets waiting to be revealed, not every truth is one humanity is prepared to face. Kafka's Toxin Puzzle. Imagine this. A wealthy individual known for conducting elaborate psychological challenges approaches you with a unique proposition. Tomorrow morning, you'll be given a vial containing a toxin. Drinking it won't kill you, but it will make you extremely ill for an entire day. Think pounding headaches, severe nausea, and complete discomfort. Here's the twist. This billionaire promises to deposit $1 million into your bank account tonight. On one condition, you must genuinely form the intention, right now, to drink the toxin tomorrow. There's no requirement to actually follow through. No one will monitor your actions. You're free to take the money and skip the drink. All that matters is that tonight, as the billionaire observes your mental state, you must sincerely intend to go through with it. Sounds simple, doesn't it? Just decide you'll drink the toxin, secure the million, and change your mind tomorrow. But here's where the dilemma reveals itself. If your plan is to abandon the action later, did you truly intend to carry it out in the first place? The billionaire won't fall for deception. They'll detect any false resolve. So how can you make yourself truly want to do something you know you'll want to avoid later? This is the heart of Kafka's Toxin Puzzle. a brilliant and perplexing philosophical scenario that pushes us to rethink our concepts of intention, logic, and free will. At first, it feels like a clever loophole. Convince yourself you'll drink it, get paid, and simply don't. But forming an intention isn't as easy as flipping a mental lever. Intentions are closely bound to what we believe we're actually going to do. You can't just choose to intend something that you already know you have no plan of doing. Try it for yourself. Can you sincerely intend to touch a red hot stove tomorrow when you know full well you won't? It's highly unlikely. That's what makes this problem so vexing. To receive the reward, you must fully commit to an intention that you'll have no motivation to follow through on once the reward is given. Some philosophers argue that the puzzle reveals a flaw in how we define rationality. Usually, being rational means doing what's best for yourself. But in this situation, being too rational undermines your ability to form the necessary intention, meaning you lose out on the reward. Ironically, logic becomes your obstacle. The scenario suggests that sometimes reaching a goal may require you to momentarily set aside your rational thinking, to persuade yourself to commit to an action you know is ultimately against your interest. But how would you even do that? One possible method is pre-commitment, setting up consequences that force you to go through with the action. For instance, you could ask a friend to destroy the money if you back out, making it rational again to drink the toxin. But that's not quite the same. The billionaire didn't request a clever workaround. They asked for a sincere, internal decision, a pure intention without manipulative strategies. Others offer a different interpretation, suggesting that this puzzle uncovers something profound about the structure of intentions. Perhaps intending isn't merely about future actions. It might involve a kind of psychological coherence, a present mental posture of readiness, even if the action never occurs. In this light, intention becomes less about behavior and more about who you are in the now, a decision that aligns with certain values or attitudes regardless of outcomes. The puzzle also opens the door to deeper questions about freedom. If you're unable to form the required intention, does that mean your choices are limited by your mental wiring? Are you truly free to intend something that you know you'll never act on? In this way, Kafka's scenario exposes the subtle constraints within our own minds, limitations that make certain decisions impossible, not because of the world, but because of how we function internally. Ultimately, there is no single answer to this riddle. The point isn't to solve it, but to explore the strange space between logic, willpower, and the complexity of human decision-making. It shines a light on the chaotic overlap of principles and lived reality, where abstract reasoning clashes with the raw mechanics of how we think and feel. So now picture this. The toxin sits before you. The $1 million has already arrived. Do you drink it? Or, more intriguingly, did you ever honestly mean to? And what does that reveal about the way we understand our intentions, our rational minds, and the inner workings of our decisions? Quantum immortality. Quantum immortality suggests you might never truly cease to exist, because the structure of reality itself could be guiding your awareness along endless paths across the multiverse. This is the concept of quantum immortality, a philosophical scenario so bizarre that it forces us to rethink everything we believe about life, death, and our place in the cosmos. Let's explore how this concept unfolds. In the realm of quantum physics, particles exist in what's called a state of superposition. That means they hold all potential outcomes at once, until something causes one to be observed. Schrodinger's cat is the classic metaphor. Inside a closed container, the cat is simultaneously alive and dead until someone looks and collapses the uncertainty. But what if the cat in the box was you? According to the many worlds interpretation of quantum mechanics, when a quantum event occurs, the universe doesn't just pick one outcome, it splits into several, each representing a different possibility. One version of you might survive a near-death experience, while another might not. From the standpoint of the greater multiverse, every possibility unfolds. Here's where it gets truly mind-bending. Your consciousness, under this framework, would only persist in the timelines where you continue to survive. Every time there's a chance you might die, your experience would carry on in the reality where you didn't. From an external point of view, people may see you die in one world, but from your own perspective, you'd keep waking up in the branches where you live. The outcome? A peculiar form of immortality. Not the kind where you're young forever or immune to harm, but a continuous, uninterrupted stream of self-awareness through the paths where you always make it through. You wouldn't notice the versions where you didn't. However, this isn't a magical escape from aging, illness, or physical decline. It only applies to moments governed by quantum probability, where survival isn't certain. Eventually, those life or death scenarios become rare, and the possible routes that keep you going will narrow and disappear. Even this form of immortality appears to have boundaries. So, is quantum immortality an actual feature of our reality? That remains unknown. It hinges entirely on whether the many worlds interpretation is an accurate model of the universe, a topic still fiercely debated among physicists and philosophers. If it's correct, then every quantum occurrence spawns infinite versions of the universe, and your awareness may be following the strand that never ends. If it's incorrect, then quantum immortality remains nothing more than a captivating mental exercise. Regardless of its truth, this thought experiment leaves us with profound questions about the essence of death, the persistence of the self, and the vast, unknowable nature of consciousness. The hallucinatory reality. Imagine a universe where what you call reality isn't something you passively detect, but something your brain actively constructs. A world in which the separation between what exists and what is imagined becomes difficult to define, and every sight, sound, or touch might be a carefully designed illusion generated within your mind. This is the intriguing and unsettling concept of hallucinatory reality, the idea that what we encounter isn't so much outside of us, but created within. To explore this concept, we must first examine perception. The human brain is engineered to decode and organize the endless flood of sensory input it constantly receives. Your eyes, for example, do not merely record what's in front of you like a camera. Instead, they transmit electrical impulses to the brain, which then interprets and builds a visual scene. This internal process occurs so fluidly that it gives you the impression of directly witnessing reality. But here lies the twist. Your brain is not giving you a raw, unfiltered version of the world. It modifies, adjusts, and even invents aspects of your experience. Why? Because the unprocessed version of reality is chaotic, confusing, and often irrelevant to your immediate needs. The brain's purpose is not to reveal objective truth, It's to generate a usable model of reality that helps you stay alive and function effectively. Think about colors. When you perceive a specific color, you're not actually seeing that color itself. You're interpreting how your brain responds to various wavelengths of light. An object might look one way in daylight and another way in shadow, yet your brain automatically compensates. Or consider the blind spots in your vision. Every eye has areas that collect no visual data, but you don't walk around seeing blank spaces. Your mind seamlessly fills in the gaps without your awareness. This mental editing is usually beneficial. It helps you identify important details, like spotting a snake in the grass or reacting quickly to a car veering toward you. Yet it also implies that the reality you think you're experiencing is, in essence, a form of hallucination. It's a structured, collective hallucination influenced by your biology, sensory systems, and memories. The situation becomes even more intriguing when we recognize how fragile this illusion is. Optical illusions can trick you into seeing motion in static images or depth in flat shapes. Your mind can even fabricate sounds, particularly when it expects to hear something. And memory, something we rely on to recall our past, is anything but fixed. It's fluid, constantly edited, and influenced by context. These imperfections in perception highlight that our sense of reality is not as solid as it appears. In extreme cases, this illusion can unravel entirely. Psychedelic substances like psilocybin or LSD vividly expose how deeply our perception is sculpted by the brain. Under these influences, everyday objects may shift, colors may shimmer or breathe, and your experience of time may become fluid or disjointed. It feels as though the world itself is changing, when in fact it's your brain rewriting its own rules for interpreting sensory input. But this hallucinatory nature of perception isn't a flaw, it's a critical adaptation. Picture an animal that perceives the world exactly as it is, without any simplifications. It would be overwhelmed, too slow to react, and vulnerable. Evolution favors organisms that process only what's necessary, distorting reality in ways that boost survival. For humans, that means constructing a simplified, responsive model of the world that highlights threats and opportunities while discarding the rest. This raises a profound philosophical question. If what we experience is shaped so heavily by our brains, can we even speak of a truly objective reality? Thinkers and scientists have wrestled with this question for centuries. Some suggest there is a real world out there, though we see it imperfectly. Others, particularly those who align with idealist philosophies, argue that reality might only exist within consciousness. And there's the most disconcerting possibility of all, that what we experience could be part of a vast simulation, something that only feels real. Hallucinatory reality forces us to question the very limits of our understanding. It teaches us that our perception is not just influenced by our minds, it's confined by them. But this isn't just a limitation, it's also an opportunity. If our brains can craft such a vivid and intricate experience of life, what else might they be capable of? Could we use this ability to invent new ways of thinking, experiencing, or even entirely new imagined worlds? Ultimately, the theory of hallucinatory reality offers a powerful realization. The world you live in is not the world as it truly is. It's a mental creation shaped by millions of years of evolution. It is a kind of internal masterpiece, unique to each person. And like all great works of art, it is layered, astonishing, and filled with mystery. What you perceive may not be strictly real, but it is your reality. And perhaps that's what makes it so remarkably profound. Brain in a vat. Consider this. You're taking a peaceful walk through a quiet park, soaking in the sunlight, feeling the wind brush against your skin, sensing the firm ground beneath your feet. Everything feels completely natural. But what if none of it exists? What if, instead of walking through a real park, you're actually just a disembodied brain, suspended in a container of nutrient-filled liquid, connected to a sophisticated computer that's feeding your consciousness a seamless simulation of life? This is the essence of the brain in a vat thought experiment, one of philosophy's most disturbing and intriguing intellectual challenges. At its heart lies a simple yet profound question. If your sensory experiences can be flawlessly manipulated, how can you ever be sure that what you perceive is truly real? The consequences of this scenario are immense. It questions the very basis of reality, consciousness, and our understanding of the world. Let's delve deeper into this disorienting idea. The brain in a vat hypothesis is a modern adaptation of an age-old philosophical dilemma. Thinkers like René Descartes once posed similar doubts, imagining a malevolent force deceiving our senses and presenting us with a false version of the world. In this updated version, the deceiver isn't a demon but a machine, an advanced computer capable of generating a hyper-realistic world, rich in detail and indistinguishable from the real one. This computer would send exactly the sensory information your brain expects: light, sound, touch, and time, all crafted with precision. You'd feel sunlight warming your skin, hear the rustling of nearby leaves, and sense the slow passage of time. But if the illusion is perfect, how could you prove it isn't genuine? You might be living inside a simulation this very moment, nothing more than a brain immersed in synthetic experience, guided by forces unknown. Though it may sound like the stuff of science fiction, this concept points to a serious philosophical concern. All your knowledge about the external world is filtered through your senses. Light travels through your eyes, sound vibrates your eardrums, pressure touches your skin. But what if every bit of that input is fabricated, mere data being fed into your brain by an external machine, and without a means of stepping outside your own perception? How could you ever verify the truth of what you're experiencing? Let's go even further. If you are a brain in a vat, what about the people you interact with? Are they also simulations? Or are they other isolated brains, each experiencing a collective but artificial reality? How would you distinguish between the two? Can you even tell the difference? Here's a more unsettling question. What became of your body? Did it ever actually exist? Or was your brain always detached, living solely within this manufactured environment? The brain in a vat scenario also casts doubt on the nature of free will. If your thoughts and behaviors arise from sensory input, and that input is entirely controlled, then are your actions truly your own? Or are you merely responding in predictable ways to artificial triggers? What does identity mean in such a reality? But let's change perspectives for a moment. What if being a brain in a vat isn't so terrible? If the illusion is absolute, you would never know. You might lead a joyful, meaningful life, blissfully unaware of the true nature of your existence. In that sense, does it matter if the reality you inhabit is manufactured? This idea aligns with a school of thought known as hedonistic utilitarianism, the philosophy that pleasure and happiness are the highest goods. If your simulated life brings fulfillment and joy indistinguishable from that in a real world, then does the origin of the experience truly matter? Which leads us to a deeper philosophical question. What defines something as real? Is it physical substance and external validation, or is it the quality of experience? If your feelings, thoughts, and relationships are vivid and sincere, are they any less authentic just because they occur in a simulation? Perhaps reality isn't something outside of you. Maybe it exists within the mind. This thought experiment doesn't merely challenge our grasp on reality. It also reveals how little we actually know. If our perceptions can be controlled or generated, then our understanding of truth becomes fragile, built on faith in the accuracy of our senses. Ultimately, the brain in a vat idea highlights how limited human knowledge truly is. Whether or not you're actually a brain floating in synthetic fluid, the questions it raises about identity, perception, and the world around us are worthy of contemplation. Perhaps the point is not to discover definite answers, but to recognize and respect the complexity of conscious experience, even if that experience is artificial. So now, consider this. Are you truly living in the physical world? Or are you, without realizing it, a brain in a vat? And if you were, would it even matter? The next time you take a walk in the sunshine, inhale the fresh air, or savor the touch of nature, pause and ask yourself one simple question. What is reality? And how do you really know it's real? Twin Earth. The sky is blue. The grass is green. Water is wet. Seems obvious, doesn't it? But now imagine a world almost exactly like ours. A duplicate Earth that mirrors every detail down to the tiniest blade of grass and the smallest droplet of water. However, there's one subtle but profound difference that turns our assumptions about meaning, knowledge, and reality completely upside down. Welcome to the strange and fascinating world of the twin Earth thought experiment. First introduced by philosopher Hilary Putnam in 1975, Twin Earth is a philosophical scenario meant to challenge how we think about words and the world. Picture a distant planet in another galaxy, or perhaps in a parallel dimension, a world that replicates Earth in every way imaginable. It has oceans, forests, cities, animals, and even human-like beings who speak, think, and behave just like us. But there's one vital difference. What looks like water on this other planet isn't the same substance we know as whole. Instead, it's made of a completely different chemical formula. Let's call it XYZ. Here's where it gets interesting. On Twin Earth, XYZ acts exactly like water. It runs in rivers, freezes into ice, boils into steam, and hydrates living things. To the people there, XYZ is water. They use the word water for it just as we do for whole. It satisfies the same needs, produces the same sensations, and appears identical in every observable way. But chemically, it's not the same thing. So what happens when someone on Twin Earth says the word water? Are they talking about what we mean by water? And when we say water, are we referring to the same thing they are? At first glance, this might seem like a simple question about words, but it actually raises deep and complex issues about how language works. On our Earth, when we say water, we're referring to Ho, a molecule made up of two hydrogen atoms and one oxygen atom. On Twin Earth, however, The word water refers to XYZ. Two very different chemical substances are being labeled with the same word. Even though they seem the same to our senses, they are fundamentally different. This leads to a profound insight. The meaning of a word doesn't just come from what we think in our heads. It also depends on the world around us. Let's dig into this idea further. You don't need to be a scientist to use the word water. When you point at a glass of it and say, "This is water," you're relying on the fact that, in your environment, the clear drinkable liquid you're pointing to is actually whole. But on Twin Earth, someone making the same gesture is pointing to XYZ. The meaning of the word water is tied to the physical reality of each planet. This challenges a common assumption that word meanings are purely based on what we believe or imagine. Instead, Putnam's Twin Earth experiment argues that meaning is partially determined by the external world. This idea is known as semantic externalism, the belief that what a word means depends not only on mental states, but also on the nature of the surrounding reality. And Twin Earth leads us into even stranger territory. Imagine you are suddenly transported to Twin Earth without knowing it. Someone hands you a glass of XYZ, and you drink it without realizing it's not whole. It looks, tastes, and feels like the water you know. For all practical purposes, nothing appears different. But chemically, you're consuming a substance your body has never encountered before. Could you tell the difference? Would it even matter to you? From your perspective, nothing has changed, yet scientifically, everything has. This highlights a major gap between how things seem and how they actually are. Just because something feels familiar doesn't mean it is. Twin Earth exposes the hidden assumptions we make, that the things we experience are always what they appear to be. The implications run even deeper. Twin Earth not only challenges how we understand the meanings of words, but also how we think about knowledge, identity, and the structure of reality itself. If the meaning of language depends on the environment, what does that say about how we share ideas and understand one another? If you can't detect the difference between Ho and XYZ, do you really know what you're consuming? And if two worlds can be visually and experientially identical, but radically different beneath the surface, what does that reveal about the true nature of existence? The twin earth concept also connects to more modern philosophical questions, like how we define what something is in science or ethics. Suppose scientists find a new element that looks and behaves exactly like gold, but isn't chemically the same. Should we still call it gold? Or take artificial intelligence? If a machine behaves exactly like a human being, talks, thinks, feels, but is made of circuits instead of neurons, should we treat it like a person? The Twin Earth Thought Experiment provides a framework to wrestle with these kinds of questions. It shows how context shapes the boundaries of our understanding and what we consider to be real or meaningful. At its core, Twin Earth reminds us of how strange and uncertain reality can be. It's tempting to believe that words like water have fixed, universal meanings, that no matter where you are, water is always water. But Putnam's experiment reveals that even the most basic concepts are tied to the specific worlds we live in. Meaning doesn't exist in isolation. It's shaped by the physical environment and the assumptions we carry. So the next time you take a sip of water, consider this. Somewhere in a distant universe, someone just like you might be drinking a clear, refreshing liquid that quenches thirst and cools the body. To them, it's also water. But chemically, it's not whole. And yet, for them, it's every bit as real. Now ask yourself, does that change what the word really means? And if it does, how do we ever truly know what we're talking about? Boltzmann brains. You believe you are sitting here, engaged in thought, or at least, that's what you think is happening. Your consciousness seems to interpret the environment, stitching together what appears to be reality through memories, sensations, and logical processes. But what if all of this, every sensation, every thought, is false? What if you yourself aren't what you think you are? What if you are nothing more than a Boltzmann brain? The concept of the Boltzmann brain arises from a paradox that lies deep within the principles of modern physics. To grasp it fully, we need to journey back to the 1800s, when physicist Ludwig Boltzmann reshaped our understanding of entropy. Building upon existing scientific ideas, Boltzmann offered a new interpretation, connecting entropy with the microscopic behavior of particles. He demonstrated that entropy, the natural progression from order to disorder, is fundamentally a matter of statistical probability. Over time, systems, whether it's a hot beverage cooling down or the entire cosmos expanding, tend to drift toward greater chaos. But here's where things take a bizarre turn. In an infinite universe, entropy doesn't tell the whole story. In rare instances, purely by chance, particles can randomly align to produce brief episodes of organization. Think of a cluttered room suddenly arranging itself neatly with no external interference. Highly improbable, yes, but in a universe with limitless time, not entirely impossible. Boltzmann speculated that maybe the universe itself came into being this way, an improbable fluctuation in a sea of disorder, spontaneously forming stars, planets, and life, if only momentarily. But what's even stranger is this. If chance events can generate entire cosmic structures, they can certainly produce something far smaller too. Instead of a universe filled with galaxies, what if a random fluctuation formed at just a single conscious mind? Imagine a brain, fully assembled in an instant, floating alone in a void, filled with fabricated memories, sensations, and a complete sense of self, yet all of it artificial. This is the idea behind the Boltzmann brain, a solitary awareness imagining a universe that doesn't exist. What makes this concept so disturbing is that, according to mathematical probabilities, forming a single brain requires far less energy and organization than forming an entire universe. From a purely statistical point of view, Boltzmann brains should be far more common than real, structured worlds. Given infinite time, it's not just possible, they become expected. This leads to a troubling question. How can you be sure you're not one of them? How do you truly know the world around you, the air you breathe, the ground beneath you, the people you interact with? Isn't just a hallucination conjured up by a disembodied brain adrift in a void? This thought experiment calls into question everything we take for granted. It asks whether the world we perceive actually exists or whether it's just a momentary illusion, a random flicker in an otherwise chaotic and unstructured existence. It compels us to examine how fragile our sense of reality might be. But should we accept that nothing is real, that our experiences are meaningless illusions? Not necessarily. Many scientists and philosophers argue against the implications of the Boltzmann brain theory. They point out that a reality dominated by such random minds would appear vastly different from the one we experience. Our universe displays structure, order, and consistent natural laws, features not expected in a universe ruled by isolated, accidental brains. Others suggest that perhaps our current understanding of entropy, time, or even the concept of infinity is flawed. The assumptions that predict the existence of Boltzmann brains may rest on incomplete or incorrect models. Alternatively, it's possible that consciousness cannot simply emerge from randomness, no matter how vast the scale of time or space. In the end, the Boltzmann brain theory doesn't provide concrete answers. Instead, it opens up a space for us to question long-held beliefs. What does it really mean to exist? How do we know our perceptions are accurate? And how do we operate in a universe where even the most improbable ideas might be possible? Because in the end, whether this universe is authentic or not, it certainly feels real. And perhaps, for now, that feeling is enough. Newcomb paradox. Imagine yourself standing before two containers. One is transparent, box A, and inside it, you can clearly see $1,000. The second, box B, is covered, and whatever it holds is unknown to you. You're given a choice. Either take only box B or take both box A and box B. Seems like a simple decision, right? Why not just grab both and walk away with more cash? But here's where things take a strange turn. The contents of box B have already been decided by a highly advanced and nearly infallible predictor. If this predictor foresaw that you would take both boxes, it deliberately left box B empty. However, if it predicted that you would take only box B, then it placed $1 million inside it. This being has an almost perfect track record. It very rarely makes a mistake. So now you're left with a serious dilemma. What should you do? Welcome to the Newcomb paradox, a philosophical puzzle that sets reasoning against instinct, free will against fate. What seems like a straightforward scenario is actually a deep dive into the mechanics of decision theory, predictive logic, and even the fabric of reality. At first, the problem appears to be nothing more than a basic risk-reward choice. Take both boxes, secure $1,000 from box A, and hope for more in box B. But here's the twist. If the predictor is as accurate as claimed, then choosing both boxes virtually guarantees box B will contain nothing. On the other hand, if you choose only box B, you're likely to receive the full $1 million. This raises the central question: do you have confidence in the predictor's precision, or do you play it safe and take both? Two opposing groups emerge from this paradox. The first are known as the one-boxers. Their reasoning is based on the predictor's near-perfect ability to foresee choices. They argue that by selecting only box B, you are likely to receive the $1 million, because that's what the predictor would have anticipated. From this perspective, trusting the predictor and resisting greed is the smartest approach. Then there are the two boxers. They take a logical, almost mechanical view. By the time you make your choice, the money is already in, or not in, box B. Your current decision, therefore, can't possibly alter something that's already been determined. So why not take both boxes and walk away with at least $1,000? To them, believing your present choice affects a past event is unreasonable. The heart of the paradox lies in the tension between these two outlooks. If the predictor is virtually never wrong, It feels like your decision was already locked in before you made it, making the case for taking only box B. But if you hold that your action now can't possibly change the past, then taking both seems like the only rational move. Both arguments are compelling, and yet there's no universally accepted resolution. But Newcomb's paradox goes far beyond being a clever thought experiment. It's a lens for examining some of the most profound philosophical concepts. It raises questions about agency and determinism. If a prediction is always correct, do you actually have freedom of choice? It also explores causality. Can a decision made now alter what was already set in motion? It even has echoes in real-world decision-making. In areas like economics, politics, and relationships, we constantly face situations where outcomes depend on trust, foresight, and assumptions about how others predict our actions. Do you put faith in the system, aiming for long-term gain based on trust? Or do you prioritize immediate benefit, even if it might cost you more in the end? Ultimately, Newcomb's paradox isn't about arriving at a single correct answer. It's about exploring how we choose, how we weigh risk, and how we confront uncertainty. Whether you align with the one boxers or the two boxers, this paradox challenges us to rethink what it really means to make a decision and what that decision says about the nature of the world we live in. So now, ask yourself, will you choose just one box or go for both? Swampman. In the depths of an isolated swamp, something utterly improbable occurs. A lightning bolt strikes the marshy waters, and by an astonishing coincidence, it rearranges atoms into the exact structure of a human being. But this isn't just any person. It's a flawless duplicate of you. It has your exact physical features, the same brain configuration, identical memories, and a personality that mirrors your own. This new entity, let's refer to it as Swampman, is a perfect match. It opens its eyes, stretches its limbs, and steps out of the swamp. It recalls your favorite songs, your childhood experiences, your loved ones. It thinks the way you do, feels as you do, and even believes itself to be you. But is it really? This thought experiment, introduced by philosopher Donald Davidson in 1987, presents a perplexing scenario that dives headfirst into questions of personal identity, consciousness, and the essence of meaning. At first, Swampman seems easy to define. If it behaves, thinks, and remembers exactly like you, wouldn't that make it you? But as you examine more closely, the illusion begins to unravel, exposing profound philosophical challenges. Let's begin with the concept of identity. If Swampman possesses your knowledge, behaviors, and patterns, does that qualify it as you? Or is there something more, something deeper, that defines who a person truly is? Perhaps it's the unique path you've walked, your experiences, the events that shaped your mind, the ties you've created with others. Swampman lacks that personal history. It only has a flawless copy of your memories, memories it never actually lived through. So does that make Swampman a fraud? If you were to stand face to face with it, would it feel like confronting yourself, or like meeting a stranger who stole your life? Now take the idea further. Suppose Swampman encounters someone close to you, your best friend, for example. It recognizes them, smiles, and initiates a heartfelt conversation about moments it remembers in vivid detail, but never truly experienced. To your friend, nothing seems amiss. They share stories, laugh together, and might never question a thing. But what about the emotional depth of those moments? Can swampmen genuinely recreate the emotional bond you had? Or is it simply echoing your past interactions, devoid of the real meaning behind them? This brings up an essential inquiry. Does significance arise from the lived journey, or can it be simulated with complete accuracy? If swampmen can replicate your behaviors and emotions, is it actually experiencing those feelings, or just running a remarkably complex program? The swampman scenario also puts pressure on our understanding of consciousness. If this entity has the same brain and neural patterns as you, does that automatically mean it's conscious? Or could it merely be performing a convincing imitation of thought? This touches on the core of what philosophers refer to as the hard problem of consciousness, the question of how physical structures give rise to subjective experience. If Swampman perceives the world as you do, that could suggest consciousness emerges from purely physical processes. But if it does not, then maybe there's something more, something non-physical, about being truly alive. Then there's the question of morality. If Swampman isn't really you, does that disqualify it as a person? Would causing it harm be ethically wrong? Does it have emotions, rights, and a will of its own? Or is it merely a hollow replica posing as a human? Swampman leaves us without concrete answers. Instead, it exposes the fragility of how we define ourselves, the people around us, and the concept of being. It questions the very foundation of personal identity, emotional connection, and human experience. If there's one powerful lesson behind this peculiar thought experiment, it's that being human is not just about what we are made of. It's about what we've endured, how we've evolved, and the narratives we've lived. The Swampman paradox doesn't hand us a solution. It pushes us to reflect on the subtle, delicate interplay between memory, experience, and awareness that makes each of us unique. And it forces us to wonder, if we ever came across Swampman, would we be able to tell the difference? Would it know the difference? And finally, does it matter? The trolley problem. The trolley problem is one of the most widely recognized philosophical dilemmas, posing a question that appears straightforward on the surface. What's the morally correct action when confronted with a tragic, unavoidable choice? Yet behind its simplicity lies a complex maze of ethics, moral judgment, and human psychology. Imagine this. A trolley is speeding uncontrollably down a set of tracks. Directly ahead, 5 individuals are bound to the railway, completely unable to escape. Nearby, there's a switch. If you pull it, the trolley will be diverted onto a different line, where only one person is tied down. Now you must decide, do you pull the switch, ending one life to preserve 5? Or do you abstain and allow the trolley to follow its current path? Initially, most people assume the answer is simple. Saving 5 lives by sacrificing one seems like the morally superior option. But then doubts arise. Does intentionally choosing to sacrifice one person outweigh the inaction of letting 5 perish? Is refraining from intervention ethically less damaging than taking an active role in someone's death? That's the essence of the trolley problem. It's not about trains or switches. It's about the ethical systems we use to determine right from wrong. 2 primary schools of ethical thought come into focus here. First is utilitarianism. According to this view, the right action is the one that maximizes overall benefit or happiness. The utilitarian would likely argue that pulling the switch is morally justified. as it preserves more lives and reduces suffering. Sounds reasonable, right? But hold on. Now consider deontology, an ethical approach centered on rules, principles, and duties rather than outcomes. A deontologist might assert that redirecting the trolley involves a conscious choice to end someone's life, which is intrinsically wrong, regardless of the result. Under this framework, doing nothing is preferable because you aren't the direct cause of harm. Now let's make the scenario more intense. Instead of pulling a lever, suppose you're standing on a footbridge above the tracks, next to a very large individual. If you push them off the bridge, their body will stop the trolley and save the 5 workers, but the person you push will die in the process. Suddenly, it feels different. The logic of sacrificing one to save many still applies, but something about physically pushing someone to their death makes the decision feel far more disturbing. Why is that? This highlights a curious aspect of human morality. We seem instinctively uncomfortable with causing harm directly, even if the final outcome is identical. Our choices aren't driven purely by reason. They're deeply influenced by emotion, empathy, and our sense of moral responsibility. And yet, this moral puzzle continues to evolve. Now imagine the one person tied to the tracks is a loved one, a close friend, a relative, or even yourself. Or perhaps the 5 people on the main track are total strangers, while the individual on the alternate track is a brilliant scientist on the verge of curing a deadly disease. Do these new details change your decision? This is why the trolley problem has fascinated philosophers, psychologists, and moral theorists for generations. It forces us to examine difficult truths about how we weigh consequences, personal values, and relationships. And it isn't just theoretical. It applies to real-life decisions too. Consider self-driving vehicles. These machines might have to make split-second choices between protecting passengers or pedestrians. Whose life should be prioritized? And who gets to make that call? At its core, the trolley problem serves as a reflective tool. It exposes our internal values, uncovers our hidden biases, and reveals how we struggle to reconcile rational thought with emotional instincts. It offers no definitive answers, and that's intentional. The dilemma reminds us that ethics are complicated, that noble intentions can lead to troubling consequences, and that some decisions simply don't have perfect solutions. So the next time you're faced with a difficult choice, or even just see a set of train tracks, ask yourself, what kind of person do you aspire to be? The trolley problem isn't merely a philosophical exercise. It's an invitation to think deeply, challenge your instincts, and confront the messy, intricate reality of what it means to be human. The Cheshire Cat Experiment. At first glance, the Cheshire Cat experiment might sound like it's been lifted from a fantastical fairy tale. But despite its playful name, this concept isn't about sly, grinning cats. It's a serious quantum physics thought experiment that turns conventional notions of reality upside down. It poses an unusual question. Is it possible for an object and one of its defining characteristics to exist separately? To understand the foundation of this idea, let's go back to Alice's Adventures in Wonderland by Lewis Carroll. In the story, the Cheshire Cat is known for its peculiar ability to vanish, often leaving behind only its wide, toothy smile. The grin remains even after the cat itself has disappeared, suggesting a surreal division between a thing and one of its features. That imaginative scene captured the attention of physicists, who began to wonder, could something just as strange occur in the world of quantum physics, where the rules of reality often defy ordinary logic? In 2014, researchers decided to put this strange question to the test through a real experiment. They worked with neutrons, extremely small particles found within atoms, and their magnetic moment, which is like a tiny compass needle embedded within the particle, pointing in a specific direction due to its quantum properties. The critical question was this: could the neutron and its magnetic moment, like the body and grin of the Cheshire Cat, be separated within a quantum system? To explore this, scientists turned to a phenomenon in quantum mechanics known as the quantum Cheshire Cat effect. At the heart of quantum theory is the idea that particles don't occupy fixed positions like they do in classical physics. Instead, they exist in a cloud of probabilities, only settling on a definite state when measured. This unusual characteristic allows for the possibility that a particle could be in one place while one of its measurable traits might be found elsewhere. Using an instrument called a neutron interferometer, which can split and later recombine the paths of particles, the researchers passed neutrons through a specialized crystal. This setup divided the particles into two separate paths. One route appeared to contain the neutron itself, while the other seemed to carry its magnetic moment. When the two paths were brought back together and the results analyzed, the outcome was astonishing. It seemed that the neutron had taken one route, while its magnetic property had taken the other. Just like the Cheshire Cat leaving behind its smile, the particle and one of its traits had parted ways. This result deeply challenges what we think we know. In classical physics, an object and its attributes are considered inseparable. A tennis ball has a specific color, speed, and position, all part of a single, unified object. But quantum mechanics tells a different story. Properties such as spin, electric charge, or magnetic orientation can become untethered from the particle they belong to and behave independently. This behavior stems from the mathematical structure of quantum theory. Particles are not described as solid, point-like objects, but as waves of probability that only become definite when measured. Observing a particle forces its properties to collapse into a single value. Until that moment, those characteristics may be in multiple places or states existing in a kind of suspended potential. The implications of this are deeply thought-provoking. The Cheshire Cat experiment illustrates that quantum reality often ignores the intuitive rules we've built from our everyday experiences. It pushes us to ask profound questions. What actually defines a particle? Can it still be considered the same entity without all of its properties? And if a particle can be separated from its traits, what does that mean for the nature of matter itself? One way to interpret the results is to say that quantum attributes are not fixed parts of an object, but instead arise through interactions and measurement. They are relational, not inherent. Alternatively, this experiment could hint at unknown layers of physics beneath the surface of what we currently understand, waiting to be discovered. Ultimately, the Cheshire Cat experiment offers a clever and insightful glimpse into the strange world of quantum mechanics. It reminds us that our understanding of the universe is still developing, and that we must be open to ideas that challenge what we assume to be true. Like the disappearing cat in Wonderland, quantum phenomena often appear to smile at us from the edges of understanding, teasing us with riddles and mysteries. And while the experiment may leave us with more puzzles than conclusions, that's part of what makes science so fascinating. Because in the end, science isn't just about having all the answers. It's about exploring the unknown, following curiosity, and discovering that sometimes reality can be just as mysterious and wondrous as fiction. Pascal's mugging. Picture this. You're heading home alone one night when a mysterious figure steps out from the darkness. But instead of threatening you with a weapon or demanding your valuables, they speak in a calm, almost otherworldly tone. I am a hyper-intelligent being from an alternate universe. If you hand over just $1 to me now, I will use my immense abilities to generate a perfect world where 1 trillion individuals live in eternal joy. Decline, and nothing happens. I'll simply vanish. Sounds absurd, doesn't it? Why would you entertain such an outrageous proposition? Yet, what if, against all odds, they're actually telling the truth? Suddenly, the stakes become almost unimaginably large. This peculiar dilemma is known as Pascal's mugging, a contemporary reinterpretation of a 17th century philosophical wager proposed by Blaise Pascal. His original idea was that believing in God is the more logical choice, since the potential reward, eternal bliss, far outweighs the potential cost if belief turns out to be wrong. The modern version, however, poses a more unsettling question. How should one act rationally when facing minuscule chances paired with colossal outcomes? At first glance, your reaction might be to laugh it off and move along. The claim is clearly outrageous, just a wild story with no proof behind it. But here's where things start to unravel. Suppose there's even a 1 in 1 trillion chance that this bizarre stranger is telling the truth. The payoff, an eternal paradise with 1 trillion happy beings, vastly overshadows your trivial $1 loss. It's simple arithmetic. A microscopic chance at an unimaginably huge gain may still make the trade-off appear worth it. However, accepting that logic opens up a dangerous pathway, what happens when another stranger appears, promising even greater rewards? Say, endless happiness for $1,000. Or what if someone demands everything you own, claiming it will save not just one universe, but an infinite number? Where does it stop? This is where Pascal's mugging becomes truly mind-bending. It takes advantage of how we normally assess risks and benefits. Under typical circumstances, we evaluate choices based on their probability and the size of their consequences. But when the rewards reach astronomical levels, like trillions of lives, our usual decision-making frameworks collapse. Even the tiniest non-zero chance begins to overpower all else, leading to conclusions that feel irrational, even ridiculous. One response is to flat out reject this type of reasoning. You might claim that the initial scenario is so implausible, it's not even worth considering. Philosophers refer to this idea as assigning an extremely low prior probability, meaning some propositions are so far-fetched that, for practical purposes, they can be treated as impossible. But then we run into another issue. Where do we draw that line? How do we rationalize dismissing unlikely events while still giving appropriate weight to real, low probability dangers, like asteroid collisions or emerging pandemics? Some thinkers suggest the problem may lie not in the probabilities, but in the way we value these extreme outcomes. Perhaps infinite rewards themselves break our calculations. Can we genuinely compare the hypothetical bliss of 1 trillion people to the immediate and tangible impact on our own life? Pascal's mugging also exposes a deep vulnerability in how we reason. If we take the argument seriously, anyone could manipulate us by making incredible promises backed by even the faintest possibility. But on the other hand, Ignoring such scenarios entirely could cause us to miss truly consequential risks. It's a troubling contradiction, forcing us to confront the boundaries of logic, ethical responsibility, and what we even consider real. So, what should you do if such a mugger does show up? Do you give them the money, just in case they're right? Or do you dismiss them with a smirk and continue on your way? There's no definitive answer. That's the point of the thought experiment, not to offer a solution, but to illuminate just how unstable our decision-making becomes under extreme conditions. Perhaps the core message of Pascal's mugging isn't about what's logically correct, but about adopting humility. It reminds us that the universe is vast. Our grasp on truth is limited, and the sense of certainty we often cling to may be nothing more than a comforting illusion. In a world where the unbelievable might actually be possible, maybe the most important choice we face is how we respond. As the mugger quietly awaits your decision, the real question lingers. How do we live in a reality where the unimaginable doesn't just exist, but might one day demand something from us? Temporal reversal. The concept of temporal reversal suggests that nothing in the fundamental laws of nature prevents time from progressing in reverse. Envision a world where shattered clocks reassemble themselves, or where a collapsed skyscraper slowly reconstructs itself from rubble to its pristine state. It sounds fantastical, but buried within the principles of physics, this idea is far less implausible than you might expect. Let's begin with how we typically perceive time. In everyday human experience, time always appears to move in a singular direction forward. This one-way motion is referred to as the arrow of time. It's the reason people grow older, the reason memories form in a sequence, and why causes consistently seem to precede their effects. But here's the paradox. The foundational equations that describe physical reality don't inherently require time to move in this direction. In fact, the math works just as smoothly in reverse. Consider Newton's laws of motion. If you recorded a video of planets orbiting a star and played it backward, the movements would still adhere perfectly to Newton's rules. Even the strange and unpredictable realm of quantum mechanics, governing the behavior of subatomic particles, does not fundamentally favor one direction of time over another. So why, then, do we only experience time in one direction? The answer is tied to entropy in simplified terms. Entropy is a measure of disorder. Imagine a clean bedroom. That's low entropy. Now imagine the same room with clothes strewn everywhere and trash piled up. High entropy. According to the second law of thermodynamics, the overall entropy of an isolated system tends to increase over time. That's why ice melts, why eggs crack instead of uncrack, and why order tends to decay into chaos rather than the reverse. It's this universal drift toward disorder that creates the appearance of time flowing forward. But here's where things get truly intriguing. What if entropy didn't always increase? What if, under certain conditions, entropy could actually decrease? If such a phenomenon occurred, whether in isolated regions of space or during specific epochs, it could theoretically allow time to run backward, at least from the perspective of those existing within such a region. Imagine a universe in which inhabitants recall events that haven't happened yet but forget what we would call their past. In this flipped framework, causes would follow effects, and the very logic we take for granted would operate in reverse. This isn't purely science fiction. Physicists have explored models where such reversals might be possible. One potential source of temporal reversal is black holes. At their cores, physical laws break down under unimaginable forces. Some hypotheses suggest that under such conditions, time might behave differently, perhaps even reverse. Another possibility is the very early universe, moments after the Big Bang. Back then, the cosmos existed in a state of incredibly low entropy. Some models propose that time might have been symmetric in both directions, or that time could have flowed outward from the Big Bang in both directions simultaneously. If such reverse time scenarios exist, why haven't we observed them? The unsettling answer is that we might not recognize reverse time even if we were immersed in it. If all your mental processes, memories, and experiences were reversed, everything would feel perfectly normal to you, just as forward-moving time feels normal to us. This opens up profound questions. Is our understanding of time simply a result of the conditions in which we exist? Could there be life forms or entire civilizations in other regions of the cosmos experiencing time in reverse, where their tomorrows are our yesterdays? And if we were ever to make contact with such entities, would communication even be possible? The idea of temporal reversal challenges the very foundation of how we view reality. Time feels like an unchangeable march from past to future, but the truth may be much more complex. The cosmos could be stranger and more enigmatic than anything we've imagined. It pushes us to reevaluate not just the mechanics of time, but our role within this vast universe. One thing becomes clear: time is not simple, whether it moves forward, backward, or unfolds in directions we haven't yet conceived. It remains one of the most perplexing puzzles of existence. And as long as there are questions waiting in the shadows of that mystery, the pursuit of answers will continue. Perhaps that's the real nature of time, not a linear path, but an ongoing journey toward understanding.